All right, well, hello everyone, good afternoon. My name is Jason Ling. I'll be telling you today about the origins of solar systems. This is some exciting research that we're doing right here at Rice, specifically within my group in the physics and astronomy department. But before we get into all of that, I'd like to set the stage a little bit first. Our solar system, our neighborhood in the stars. For millennia, our solar system was the only known example that we had of planets orbiting around a central star. It wasn't until 1992 when we first started discovering these exoplanets, these other planets revolving around other stars. Since then, exoplanets have taken the field of astronomy by storm, raising such provocative questions such as, could we one day even live on these other planets? The search for answers has just begun in terms of looking at these other newly discovered solar systems. And in fact, one such system I'd like to introduce you to is something called TRAPPIST-1. This is a system of 7 planets orbiting around a central star. And although in the picture here, the size scale between the star and the planets is not to scale, the distances are, however, which makes you look at this and say, this looks like a miniature version of our own solar system. And in fact, you can actually fit the entire TRAPPIST-1 system well within the orbit of Mercury around our sun. Now this just goes to show the incredible diversity of solar systems that exist out in the galaxy. And in order to understand this diversity, we need to first really understand where solar systems come from. So how exactly are they formed? Well, astronomers believe that solar systems begin their lives in these massive clouds of gas and dust. Eventually, a clump of this huge cloud begins to rotate and collapse on itself. As it collapses, it speeds up its rotation thanks to the conservation of angular momentum, and it flattens out into a disk. And within this disk, we believe there could be things such as lots of turbulence, vortices, and even these spiral density waves that arise. And these waves can begin to clump up themselves and produce these kind of masses of just gas and dust. And it's possible that these clumps are the footprints for planets that can one day be formed. So how do we go about actually trying to observe this? Well, that is where my group comes in. We use the Atacama Large Millimeter Array, a radio telescope located in Chile. It has 66 dishes the size of houses that all work together and point at a single object in the night sky, and it takes a picture of it. So what kind of pictures do we get? Well, something like this. These are real scientific images of these protoplanetary disks that I mentioned before. One thing to note is that these disks are huge. You could easily fit our solar system inside one of these. And in fact, like this. What you see in the center right there is the orbit of Neptune and Pluto in our own solar system orbiting around the sun to scale according to these protoplanetary disks. You can see that these disks are massive. One other thing that you can note from these disks is that they have these rings and gaps within them. And what does that mean? To be honest, we don't really know. That is one of the beauty of doing this kind of research. We don't know exactly what causes these rings, but one popular theory is that planets, in the process of formation, carve out these gaps of material. And in fact, one can run these complex computer simulations, assuming that you have a planet within this disk, and you can watch as gravity pulls material onto this planet as it rotates around. And in fact, this may lead to these gaps that we can observe. Now, gaps and rings are just one of the many questions that we have about this formation of solar systems. There are lots of other questions, including exactly how planets form, how can we tie this to the observations of mature solar systems that we see today. And of course, as always, there are lots of potential unanswered mysteries out there. But I'm afraid I'm out of time. Thank you all for your attention, and I would be happy to take questions.